Good afternoon, I'm Mr. Ish. Thank you for joining me for this video. We are continuing here with this topic on conic rotations. In this video, we're looking at a single and a specific question. We have x squared minus 10xy plus y squared equals minus 1. Our goal is to eliminate the xy term by rotating the axis and then see, based on the xy and the x prime, y prime system, what it is that we are dealing with. We have to determine the degree of rotation involved, and we can do that. We have a formula, cotan 2 theta is equal to a minus c over b. We have a, c and b terms. The coefficient of x squared is a, that for y square is a c, and then this xy term has a coefficient of representing the b, which is a minus 10. But when you do all of this, you end up getting a 0. 0 divided by minus 10 is 0. When you do the arc cotan of that 0 and you divide by 2, we see that theta is equal to pi over 4 or 45 degrees. Now that you've determined the degree of rotation, we have to see what it is in terms of these x and y substitutions that will take place in the procedure that will occur, the rotation of axis procedure. We know x is equal to x prime cosine theta minus y prime sine theta, and we also know that y is equal to x prime sine theta plus y prime cosine theta, and everything has to fall in play. But remember, cosine pi over 4 45 degrees and sine pi over 4 45 degrees is always 1 over root 2. So that's easy. When you run everything through here, you'll have a x prime minus y prime over root 2. For here, you'll have a x prime plus y prime over root 2. If you were to do this, you would end up with that. And now what you have to do is take these items here, these expressions, and put them and substitute them here in places of x and y, and that right there will eliminate your xy term. But it will be a bit laborious. We have x, we have y. The x is this x prime minus y prime over root 2 whole square, and then we have a minus 10xy, and you know you have to start plugging away. And we will plug away. We'll put the y term here, x prime plus y prime over root 2, and then we have to do the y square. We have to do x prime plus y prime over root 2 whole square is equal to minus 1. Now look, everything here has the same denominator, so what we can do is bring everything here under the same denominator, which when squared will become a 2. We'll just open up the stuff here on the top. We'll have a x prime whole square plus y prime whole square minus 2x prime y prime. This is like a minus b whole square. You're getting a square plus b square minus 2ab, and we just run through everything else. We'll have a minus 10x prime whole square because we have to do this part, then we multiply it by 10. And then we'll have, of course, here a plus 10y prime whole square. If you were to open it up and do it on the side, it'll verify what I'm putting for you over here. It's a minus b times a plus b. There's no intermediate term which will come in. And now over here you'll have an x prime whole square plus 2x prime y prime plus y prime whole square is equal to minus 1. But you see how we have this everything over 2? You can take everything across and equal it and make it a minus 2. Now we have to consolidate everything here. This cancels out. 2x prime y prime cancels out with that. Let's look at our common terms. You have a x prime whole square, x prime whole square, and x prime whole square. You have a 1, 1, and a minus 10. That's a minus 8 x prime whole square. Then now let's look at your y prime whole squares. You have this positive, you have a positive, and then a positive. That's a 12 y prime whole square is equal to minus 2. Now take the minus 2 and divide everything by minus 2, and you'll see everything will take a good form. And I'm going to put everything for you right over here. When I'm doing this, minus 8 divided by minus 2, I'm getting a 4x prime whole square. Over here, I'm getting a minus 6y prime whole square is equal to, I'm getting a 1. When I'm looking at that, I'm seeing a hyperbolic, and I'm seeing something which looks like this, over 1 over 4 minus y prime whole square over 1 over 6 is equal to 1. It very much looks like an x square over a square minus y square over b square equals 1, a horizontally directed hyperbola, except this right here, this equation right here represents your equation of this right here in standard form. If someone told you to convert this in standard form, that right there is your answer. X prime whole square divided by 1 over 4 minus y prime whole square divided by 1 over 6 equals 1. It's a standard form of a hyperbola without the xy term. but it has been written here in the x prime, y prime system. It has been written in that. Now what we need to do is determine our vertices and demonstrate a graph for both systems. The determination of vertices is not hard. We have something here in the x prime, y prime system, and we'll have a vertices in the xy system. The xy system is your original system which you started out, and this right here is your x prime, y prime system. We know what the vertex here is. We have a square here is equal to 1 over 4. Therefore, a is equal to 1 over 2 plus and minus 1 over 2. So your vertices based on the x prime, y prime system derived from the x prime, y prime equation is going to be, and remember it's a horizontally directed hyperbola, it will be a minus 1 over 2 comma 0 and a 1 over 2 comma 0 on your x prime, y prime system. Now how do we determine this? The vertex or the vertices in this system, you have to take these values here and plug them in here systematically, and I'll do them. I'll focus everything here in this x equation, then I'll focus everything with regards to the y equation. Focusing those into the x equation is this. I'm getting this. But remember we have zeros over here, so it's easy. I'm getting a minus 1 over 2 minus 0 over root 2, and I'm getting a positive 1 over 2 minus 0 over root 2. I put this set, then I put this set in the x equation, and this is what I'm getting. So I'm getting a minus 1 over 2 root 2, and then I'm also getting a 1 over 2 root 2, and that's what I'm getting. These are my x-axis values. I'll clean it up all for you momentarily, and now I'm going to put these same coordinate pairs but into the y equation to get these y coordinates. When I'm doing them in the y equation right here, I'm getting here a minus 1 over 2 root 2, and I'm getting a positive 1 over 2 root 2. Think about it. I'm putting a minus 1 over 2 here. I'm getting a minus 1 over 2 over root 2. The zeros are meaningless, and I'm getting a 1 over 2 over root 2, which translates into this. So I'm getting a minus 1 over 2 root 2, and here I'm getting a 1 over 2 root 2. So everything is done up here. My vertex or my vertices in the xy system, and let me write them out for you. Minus 1 over 2 root 2 comma minus 1 over 2 root 2, and then the other one is 1 over 2 root 2 and 1 over 2 root 2, your x and y coordinates and your x and y items respectively. Now you have everything developed over there to demonstrate the graph of everything here. Remember, the graph is exactly the same for both, except you have a rotation of axis. And how do we demonstrate that? This is how we do it. We focus here on the xy system first. The xy system was a hyperbola which had these vertices, and let's graph them out. You know, you're looking at a minus x minus y, that's in the third quadrant, positive positive in the first quadrant, and you can estimate everything over here. 1 over 2 root 2, 1 over 2 root 2, we can just pretend it's coming right over here, and the other one is coming right over here. You can take a calculator and get a good numerical value, and your hyperbola would look something like this. Remember, I'm doing here everything with the hand. That's what it's looking like. In my x and y system right here, I have a hyperbola with these vertices. Focal points would be somewhere over here, and then you could have asymptotes, but we're not determining all of that. Now in the x prime, y prime system, those are our vertices, but that system has a 45-degree rotation of your axis. You see this? You rotate everything 45 degrees, you develop a new set of axis, your x prime, y prime axis. In this system right here, your things are minus 1 over 2 with relation to this x-axis, your modified x-axis. This right here would be your 1 over 2 comma 0, this here would be minus 1 over 2 comma 0. How can we verify that indeed everything here is good? You can do so by calculating the r value. What is this r value? It right here is basically the hypotenuse. If supposedly you have any point, from the origin you can connect it, and then you can look down, you have x, y, you have an r. Calculate the r value. If you calculate the r value, they're identical, then you know you're good. When you're looking over here, you have an x and a y. X square plus y square, or x square plus y square equals r square. In that system right here, your r value is 1 over 2. It's easy. 1 over 2 square plus 0 square, you square root that, you still get 1 over 2. Now when you take either of these, your x and y, you square each and you do the square root of their sum. I'll just take the positive values. I'll do 1 over 2 root 2 whole square, that's my a square, plus 1 over 2 root 2 whole square, that's my b square, is equal to c square, or c square is also the same thing as r square, x, y, and r. Anyhow, what are you getting? You're getting a 1 over 8 plus 1 over 8. 1 over 8 plus 1 over 8 is basically a 2 over 8, which is a 1 over 4, but when you root it, you get a 1 over 2. And we know here r in both systems is 1 over 2. R represents the distance here from the origin to your vertex, which here represents your point. And they're both the same in both, so you're good. In both instances, the r value is good. So this right here represents your equation in the standard form of this. This right here is an equation of a hyperbola with an xy element. This here is an equation of hyperbola with the xy removed by the procedure of rotation of axis by 45 degrees. The procedure is here before you. Everything here with regards to the vertex, vertices, x prime, y prime, and xy system. If there are any questions regarding this, you can just leave them in the comments. That's all I will say about this. Thank you for watching. Have a nice day.